Let's learn about packages. What are packages? You can think of packages as a collection of classes, but those classes are related to each other. So if you're creating a program where you have similar types of classes used for similar things, you might want to put those classes in a package. So we will learn about encapsulation, but just keep this in mind that package in Java is a mechanism to encapsulate a group of classes. And it has a few advantages, and we'll look at what they are. But before that, let's go and understand this through an example. Let's say you're creating different parts of a car, and you're creating classes for each part. So let's say at first you create an engine class, and then let's say you create a wheels class, and then let's say you create a chassis class, then a steering class, a gears class, and brakes class. So all these different classes are different parts of a car that you're trying to model using object-oriented programming. So let's create these classes, but when we create these classes, we want to create them in a different package. And we will name that package as car. Great, so how do we create packages? Remember that com.company is a package. And if we want to create a package, we want to create it in the source folder, all right? In the package, if we right-click, we would want to create classes. And we can also create packages in a package, but that would be a sub-package. So if we want to create a new package, just like com.company, we would want to create it in its parent folder, which is source. So right-click on that, say new, and click on package. And we'll name this package car. Great, now we have a car package. And inside this car package, we'll create all of our different classes. So first we'll create an engine class. We'll right-click, click on new, and then say Java class. Now we have an engine class in the car package. Now let's create the other classes as well. Great, now we have all these different classes: steering, gear, engine, wheel, and so on. You see, on top of all of this, the package is mentioned. So when we create a class, we also mention what package it belongs to. And when you do this in IntelliJ, it automatically puts this line on top saying that this class belongs to the package car. In the same way, if we go back to the package com.company where we had the other classes created, if we go to the math-utils class, you'll see that the package mentioned there is com.company. And also the main method is in the main class, which is a part of com.company package. Great. Now, let's say we have a company named XYZ that creates cars. And let's say that we want to create a software that manages the employees of XYZ company. So let's say the name of the company is XYZ Cars. And let's say it has 3 different departments. Let's say it has a department named marketing. Let's say it has another department named sales. And let's say it has another department named engineering. So we would want to create packages for all 3 of them differently because the employees and managers in those different departments need to be differentiated somehow, right? So we would want to first create a package for the sales department. So let's do that. And in the sales department, we'll have different sales employees and sales managers. So let's create those classes in the xyz.sales package. So now we have 2 classes, an employee class and a manager class in the xyz.sales package. Let's create another package in the source folder named xyz.engineering. And also let's create a third package named xyz.marketing. So when we do that, we create this package, we say xyz.marketing. You'll see that xyz.marketing does not become a package just by itself. What IntelliJ does is that it creates an XYZ folder and puts marketing, engineering, and sales inside that XYZ folder. So packages are just a way to make sure that you have a folder structure. So if we now create an employee class for marketing and a manager class for marketing as well, and we'll also create a manager class for engineering and an employee class for engineering. Great. Now we have packages for 3 different departments in XYZ Car Company, and each of those departments have their own employee and manager class. How does the folder structure actually look? So wherever you installed IntelliJ, you'll have a folder named Idea Project. And if you go in there, you'll see all the different projects that you've created in IntelliJ. So the project that we're currently working on is Intro to Java 3 February 20, and this is this project. So if we go in there, you'll see that you have the source folder and the out folder, exactly how it's mentioned here. So if we go into the source folder, we'll see that we have 3 different packages already there. We have car, we have XYZ, and we have com, right? So if we go in com, we'll see that there's a folder named company. You see, we have a folder named company inside com, just exactly how it's mentioned here. And in company, we'll have the 3 different classes that we created, the Java files, right? In the same way, if we go back and we look at the XYZ folder, you'll see that all these 3 different packages that we've created exist there. And inside these packages, let's say the engineering package will have the engineering employee and engineering manager class that we've created here. In the same way, in the sales package, you'll have the employee and manager class for the sales part. If you go to the car package, you'll see all the different classes that we've created in the car package. So this is how packages are stored in your computer. And this is the folder structure that they follow. Now you would understand that XYZ is a package, and inside this package we have 3 different packages. There's engineering, there's marketing, and there's sales. So engineering, marketing, and sales are sub-packages of the XYZ package. So you see, one of the advantages is that we're preventing naming conflicts. We've named our classes employee and manager for all 3 of these departments, all 3 of these different packages, but they don't conflict with each other because they belong to different packages. So we can prevent name conflicts, and that is an advantage of using packages. It also makes searching and locating and usage of classes easier, right? And as we'll see later, we can provide controlled access. Just like we used words like private and public, we can use words like protected, and that will allow us to have package level access control. And we'll see how those things work in more detail. Just for now, understand that creating packages allows us to have controlled access on our classes, the variables and the methods in those classes. And all of this is a part of data encapsulation, and we'll learn more about that in the next few videos. So you see that all we need to do is put related classes into packages. After that, we can simply write an import class from existing packages and use it in our program. So a package is a container of a group of related classes, where some of the classes are accessible and are exposed, and others are kept for internal purposes. And we can reuse existing classes from packages as many times as we need in our program. So let's say now we are working in the engineering manager class, right? And somehow we need to add up their salaries or do something related to some mathematical operations, right? You remember we already have a mathutils class in our com.company package. So can we use the mathutils class here somehow? Yes, we can. How can we do that? At first, we write import and then com.company, which is the package name, and then the class name. And when we do that, when we use this import statement, we can now use mathutils class in this class, because now we've mentioned what package it comes from and what the name of the class is. And we've used the import keyword. So it imported everything related to mathutils in this package, and now we can use mathutils in this package. So we can create a mathutils object named, let's say, A, and we would say new mathutils. Let's say we have a random method, like some method. We can actually now use the object that we've created here, the instance of the mathutils class, to access the mathutils methods. So when we say A and then we press dot, you see we have the different methods available that were public, right? And remember that public allows you access anywhere, right? But also see that the ones that we defined as private, which were subtract and the variable named any variable. So the attribute any variable and the method named subtract are not present here because we defined them as private in our previous video, right? But because the other ones were public, we can now use them here as well. And all we need to do in order to use the different methods of mathutils is use the import statement. So there are many built-in packages in Java that you can import and use in any of your classes and in any of your methods. For example, you have a lang package that is already built in Java, and you can use that to get language support classes. There's also another package named IO that helps us with input and output operations when we're dealing with files and things like that. We have a package named net that supports networking operations. We have a package named util, which contains utility classes for implementing data structures. So there are many different packages in Java that we can directly use. And I'm sure you'll see that as your knowledge in Java increases and you code more and more using this language. So that's it about packages. Let's move on to some of the other access modifiers.